Okay. So all of these are examples are not directly on our unit circle. They're numbers on our unit circle. Okay. But we have to rotate a different direction in order to figure out where it is. Or sometimes we have to go around the unit circle more than once. So for example, 450 is greater than 360. So we need to find, last week we talked about coterminal angles. So to figure out what angle would be coterminal with 450, because coterminal angles have the exact same terminal side, which means they have the same sine and cosine and tangent for that angle. So for 450, that is greater than 360. So what that's telling me is I am going to go around the unit circle a full revolution, but then I'm going to keep going. So if I take 450 and I subtract from it 360, I actually get 90 degrees. So what that tells me is that the sine of 450 is the same as the sine of 90. So my rotation, I'm going around one full revolution, then I'm going around and I'm going to stop right here. So the sine of 450 degrees is 1. Because sine is your y value. So that equals 1. For our second example, the cosine of 5 pi, so 2 pi is equivalent to 360. So what I have to do is subtract 2 pi. I can actually subtract it twice. So if I take 5 pi, so this means I'm rotating around once, and then I go around a second time, and then I stop at pi again. So 5 pi minus 2 pi minus 2 pi is simply pi. So I'm really finding the cosine of pi. And the cosine of pi is 0. So that would be your answer. So negative, we are rotating clockwise. So I'm rotating 135 degrees. And if you rotate 135 degrees going clockwise, where would we land on the unit circle? So 135 degrees rotated clockwise would mean I would go this way. Oops. So this is 90 plus another 45. So it actually land right here. So this is my coterminal angle. Another way to do that would be to simply add 360. So the tangent of negative 135 is the same as the tangent of positive 225. And to find tangent, we have to divide sine by cosine. For our 225, the cosine is negative root 2 over 2, and the sine is negative root 2 of 2. So when you divide them, you get a positive 1. And now 17 pi over 4. So that's greater than 2 pi. So I'm going to subtract from that 2 pi. So let's take that 17 pi over 4, and subtract from that 8 pi over 4 to find our coterminal angle. And that is 9 pi over 4. Well, 9 pi over 4 still is greater than 2 pi. So we need to subtract it again. So let's subtract that 8 pi over 4 one more time. And we end up with just 1 pi over 4, or pi over 4. So we're looking for the sine of pi over 4 on your unit circle. So find pi over 4. And the sine is your y value. So it would be positive root 2 over 2. I am going to extend the due date for homework 2 till tomorrow. So if you have not submitted that, I am going to change that. And our test now is pushed to, our quiz, not test, is pushed to next Wednesday. So later on in the day, if you check Canvas for our updated schedule, I will get that updated. So quiz is next Wednesday. Homework 2 is due on Thursday. And again, I'll update that soon. Okay, any questions about our bail work? Because some of these questions are in our homework too. Okay, so we're going to continue what we started yesterday in 6.3, where we have to find the remaining trig values. So take a couple minutes to copy down example 2, part A, and then I'll be back on shortly and we can work through it together. So the first thing we need to figure out is what quadrant are we in? So the clues that they told us is that tangent equals positive 1/2 and the sine of theta is less than 0. So tell me in the chat if you know which quadrant would have a tangent that equals positive 1/2 and a sine that is less than 0. And you can send me a direct message if you don't want to send it to everyone. So if a number is less than 0, this means less than 0. What kind of numbers are less than 0? Are positive numbers less than 0 or negative numbers less than 0? Negative, okay. So what this is telling me is that the sign is negative. So if it says that an angle is less than 0, then that is the hint to tell you that it's negative. So sine is negative. Sine is negative. And the tangent, if we look at this ratio, that's a positive 1/2. Tangent is positive. So how about you focus on where is tangent positive? There's only 2 places where tangent is positive. So tangent is positive in quadrant 1 because everything's positive, and it's also positive in quadrant 3. But in which one of those quadrants? So that means I'm automatically crossing out 2 and 4. So which one of these quadrants has a sign that is negative? Would that be 1 or 3? So we would be in quadrant 3. So we're in quadrant 3 because in quadrant 3, tangent is the only thing positive. Everything else is negative. So that's kind of important. So we're in quadrant 3. So what I like to do is just write as a reminder that tangent is going to be positive and its sister. The other 4 ratios are going to be, the other 4 are going to be negative. Okay, so they told us tangent, and let's find the other 5. Because yesterday they gave us 2, we had to find 4. Today they only told us 1, we have to find 5. The easiest to find is cotangent, so let's go ahead and get that done. The cotangent of theta is going to be the reciprocal of 1/2, which is 2. Okay, so that's the only thing we can find without doing the Pythagorean theorem, because tangent is equal to opposite over adjacent. And in order to find the other ratios, I need to find the hypotenuse. And we're going to do that using the Pythagorean theorem. So let's go ahead and do that. So c squared equals, because hypotenuse is c, 1 squared plus 2 squared. So c squared equals 1 plus 4. C squared equals 5. So my hypotenuse is the square root of 5. So on my right triangle, I have my hypotenuse, which is the square root of 5. I have the opposite, which is 1, and adjacent is 2. Okay, so let's find our other 5. So let's start off with the sine of theta. Sine is opposite over hypotenuse, so that would be 1 over root 5. We have to rationalize that. And that is my final answer for the sine. The sister for sine is cosecant. So cosecant of theta is the reciprocal of sine, or hypotenuse over opposite, which means you have root 5 over 1. Or you could just say root 5. And then we have the cosine. The cosine is adjacent over hypotenuse. Adjacent is 2 over root 5. We have to rationalize that. And then the fifth one is the secant. And the secant is equal to the hypotenuse over adjacent. So now I usually write them all out and then I go back in and put my negatives, okay? So of these 5 that I found, only tangent and cotangent are positive. So the only one that can stay positive is cotangent. I actually circle that in green. So let's go back in and put our negative with these 4. Because remember, we're in quadrant 3. And in quadrant 3, sine, cosine, and the sisters for sine and cosine are negative. So now that I do that, I'm going to go back in. I'm going to put my negative in here. So that's negative. Make sure you can see that negative sign. This is negative. This is negative. And so is secant. So I think we have time to do another one. And I'm going to skip around a little bit. Okay, so let's go ahead and do this one. So take a minute, copy this example down, and we will work through it together shortly. So secant is a sister to cosine. So secant is actually, let me write this as a fraction. Secant is hypotenuse over adjacent. So it says that the secant of theta is 2. Remember, every number can be written as a fraction over 1. So, excuse me. So the hypotenuse is 2, the adjacent side is 1. So secant and its sister cosine, they're positive. And again, sine is less than 0. So sine is negative. So what quadrant is cosine positive? Cosine and secant go together. So which quadrant is cosine positive and sine negative? And that would be 4. Exactly, good. So we're in quadrant 4. So that's just important. So we just need to know that in quadrant 4, cosine and secant, those are the only ones that will be positive in the end. And just like you saw in the last one, I usually just find all of my ratios and then add my negatives at the end. Kind of scrunched up. Hold on, let me. There we go. All right, so let's find, so the easiest thing we can find is cosine. So we can just do that one, get that over with. Cosine of theta is the reciprocal of secant, so it's just going to be 1/2. And that's the only thing we can find without doing the Pythagorean theorem, because we need to know the opposite. The other 4 sides, the other 4 ratios, we need to know the opposite. So we need to do Pythagorean theorem. So my hypotenuse is 2, so the hypotenuse is C. And that's going to equal my adjacent side plus, I don't like to use an O because an O looks like a 0. So I'm going to use X. But I'm solving for opposite. So let's go ahead and find our adjacent side, our opposite side, sorry. So 4 equals 1 plus x squared. Subtract the 1, 3 equals x squared. So we have the square root of 3 is equal to our opposite. So I'm going to use these 3 to find my last 4. So we have secant and cosine. So let's go ahead and do sine and secant. So sine of theta equals opposite over the hypotenuse. So opposite is root 3. The hypotenuse is 2. And then we're going to find the sister, which is cosecant. Flip your sign ratio. We have to rationalize it. So the tangent equals opposite over adjacent, which is root 3 over 1, or you could just say root 3. And then the cotangent is adjacent over opposite. And we have to rationalize it. So now I'm going to go back in and add my negatives. So only cosine and secant get to stay positive. So I'm going to put my negative with the other one. So this is negative, this is negative, negative, and negative. Okay, so I'm actually going to end there. Check Canvas around 6 period, because that's my prep. I will update the Canvas page with our due dates. If you don't have any questions, I will see you in class tomorrow. Have a great day.